Hello everyone, I'm Dr. Vidut Kumar Das, and today we are going to discuss about junction diode. So in this short video we'll be discussing about junction diode, then how junction diode behaves when potential difference is applied on them, and what are the applications of junction diode. Now let's talk about what is a junction diode. So first we have to know that a junctions between a P and N type semiconductor is most important in modern electronic applications, since this forms the basis of semiconductor devices like diodes, transistors, etc. etc. Now when acceptor type impurities are introduced into one half and donors into the other half of a single crystal semiconductor, a PN junction is formed. So this is a PN junction diode. This part is a P-type semiconductor and the right hand side is the N-type semiconductor. So this is the symbol of a PN junction diode. So the P-type semiconductor is represented by this arrow, whereas the N-type semiconductor is represented by this line. So this is basically represent the directions of the current flow through the PN junction diode. Now the PN junction may be a step-graded junctions or a linearly graded junction. So in a step-graded junctions, the acceptor or the donor impurity density in the semiconductor is constant up to the junctions. On the other hand, in a linearly graded junctions, the impurity density varies almost linearly with distance away from the junctions. And this is the photograph of a PN junction diode. So in order to identify the P and N type semiconductor of this diode, so a strip, a silver colored strip is always given at the one end of this junctions diode, and this strip recognized as the N type semiconductor. And the far end of this diode where there is no strip is P type semiconductor. So you have to identify a diode in your laboratory by this silver color strip only. Now let's see how the electrons and holes move across the junctions in a PN junctions diode. So first of all, we need to know that N-type semiconductor contains electrons as majority carriers, holes as minority carriers, and immobile positive ions. Whereas in P-type semiconductors, it contains holes as majority carriers, electrons as minority carriers, and it contains immobile negative ions. Now let's consider this is the schematic diagram of a PN junction diode. So the left hand side is the P-type semiconductor, whereas the right hand side of this semiconductor is a N-type semiconductor. So as we have discussed that P-type semiconductor contains holes as a majority carriers, whereas in N-type semiconductors the majority carriers are electrons. So due to the density gradients of electrons and holes in P and N-type semiconductors, so electrons and ions move across these junctions, leaving behind these immobile positive and negative ions. So after crossing these junctions, the electron and holes recombine each other, and thus leaving the positive and negative ions in the vicinity of the junctions. So these positive and negative immobile ions form an electric field, which is known as the barrier electric field, and this electric field is responsible to minimize the further flow of electrons and holes across these junctions. So at equilibrium, this electric field is so strong that it will not allow any flow of electrons and holes across this junction. Now, since the vicinity of the junction is depleted of mobile charges, it is called the depletion or the space charge region, and the typical thickness of the depletion region is 0.5 micrometer. Now, due to the existence of a barrier field across the junction, transfer of any electrons from the N side to the P side requires the expenditures of an amount of energy which is termed the barrier energy. The magnitude of the barrier energy depends on the width of the uncovered region. An equal amount of energy is involved when a hole from the P region is moved to the N region. Now let's talk about how to bias a PN junctions diode. There are two ways to bias a PN junctions diode, that is a forward bias and reverse bias. So in case of forward bias, the P-type semiconductor is connected to the positive terminal of the battery, whereas negative terminal of the battery is connected to the N-type semiconductor. Now, due to these connections, the holes in the p-type semiconductor and the electrons in the n-type semiconductor will experience a force due to the potential difference provided by this battery, and this force causes them to move towards the junction. This reduces the width of the uncovered charges and the height of the barrier, that is the barrier energy, and the magnitude by which the barrier energy is reduced is given by electron volt. Now, due to the reductions of the barrier height, the current flow due to the majority carriers, that is holes from the p-type side to n-type side and electrons from the n-type side to the p-type side will increase. On the other hand, the minority carrier current flowing in the directions opposite to the majority carrier current is not affected by the forward bias. This is because the minority carrier current depends only on the temperature. On the other hand, in the reverse bias, the p-type semiconductor is connected to the negative terminal of the battery, whereas the positive terminal battery is connected to the n-type semiconductor. And because of these connections, the holes in the p-type semiconductor will move towards the negative terminal of the battery, whereas the electrons in the n-type semiconductor will move towards the positive terminal of the battery. And because of this, the width of this depletion region or the barrier height will increase. However, the minority carriers which travels down the potential barrier remains unaffected and give a small current. This current is called the reverse saturation current. The reverse saturation current increases with temperature of the diode, but is largely independent of the applied reverse bias. Now let's talk about the IV characteristic of junctions diode, that is how the current varies with respect to the potential difference applied to the PN junctions diode. So the current flowing through the PN junction is given by these relations, where IS is the reverse saturation current, V is the potential difference applied to the PN junction diode, N is a constant, it's depend on the types of the semiconductor, and K is the Boltzmann constant, and T is the temperature. So from this graph we can see that, so in case of forward bias, as the potential difference increases, and the forward current also increases, and it increases exponentially. On the other hand, in case of reverse bias applied to the PN junction diode, the reverse current varies very slowly, and at a point the reverse current increases very sharply. And the PN junction diode operating in this region is called the breakdown diode. So diodes are applied in a number of electronic circuits and equipments, and one of the most important applications of diode is as rectifier. So rectifier means converting the alternating current into direct current, and most of our household electronic equipments, it requires a direct current, and therefore a diode is required to convert the alternating current into a direct current. The other applications of diodes are that it's applied in clamping circuit, voltage multiplier, light emitting diodes, and most of the direct current power supplies.